Hello everyone, welcome back to channels. I am Ram. In today's video we are diving into two very important concepts in machine learning, overfit and underfitting. So before starting this video, if you are new to the channel, so guys please make sure like, comment and subscribe my channel. So now let's get started. So I am just moving to the good model, that means is the generalized model. The example I have taken the same. I have trained the one model using the NumPy library Matplotlib, and then the model is the same linear regression, and then the performance matrix is the mean square errors, and then I have randomly generated the data with help of the NumPy, and then finally I have split the data into independent and dependent variables. And here the main things you have to be understand with respect to the degree. The degree is the nothing, this is the quadratics, is the degree I have taken in this particular case is 2, right? And then with help of this degree 2 I am going to train this model, and the model is the same. I fit this model, and then finally we predict this model, and then we have also the performance matrix is the mean square error is the same, and then we are going to plotting this particular model. So after plotting these models, the output what I am going to get. So now let's try to understand what this plot is basically indicating. See, the true function is nothing, this is a no noise, and then the good fit model is the degree 2. In this particular case I have taken the degree 2, and then previous I have taken the degree 1. That times the models was the underfit. When I taking the degree equal to 1, see the degree equal to 1, that means this model is underfit. And if I just take the degree equal to 2, that means my model is good. Why I am saying this the good models? Because see, we are increasing the model complexity with help of the quadratic polynomial degree, right? See, this green line is nothing, this green line is representing, this is the model predictions. This green line is nothing, this is the model predictions. This is the model prediction. So you can able to see there the how the closely follow the true curve and the noisy data. Yes, we can able to see there. But also you can able to see there the training error is a much lower compared to the underfit. If I just see here, it's so lower, it's not a big difference. But with respect to if I just talk about the underfit models, see the training errors, the huge difference between this curve and this data points, it's a much different. But with respect to the good model, see we cannot tell this model is either overfit and underfit, because see this the training error is a much lower, there is not much difference, it's lower. And if I just talk about this, the mean absolute error is a training 2.53, right? 2.53 is in this the good model. And if I just talk about the underfit is a 3.42. that means definitely this underfit model is a huge different. And if I just talk about the generalized, which is the best model, there is my training mean absolute error is a 2.53, which is absolutely good, right? So this means the model learned the underlying pattern well while ignoring the noise. So in this particular case, what I am going to say, this model is a generalized model. Because of why? Because see the model perform well with the training data set and also with the testing data set. So now let's talk about the overfit. The overfit scenario, I have taken the same example with respect to the good fit and the underfit. Okay, the same example, the library is the same NumPy, Matplotlib, and then the polynomial features, and then the model is nothing, the linear regression, and then the performance matrix is the mean square errors, and then I have just with help of the NumPy I have generated the data, and then we split the data into the independent and dependent variables, and then finally we fit the model. But this time I am going to take the degree is equal to 15. It's very complex, super complex. See the degree equal to 15, and then finally we fit the models, and then we predict, and then we are plotting. Let's execute this code. Now let's try to understand what this plot is basically indicating. See, we fit the very complex models of polynomials of the degree using the 50. Now see these blue lines, this blue lines is the wiggles access to pass through the almost every training point. See, every training point it's passing, every training point. See this blue line almost passing every training point. This blue line is passing to the every training point, right? You can able to see this blue line. Here you can see the training mean absolute error is a 1.82 and the degree is 15 and there is a true function is a no noise, it's okay. But you can see this blue line is passing through the all the training data set. This blue line is passing through the all the training data set. So if this fit to the noise in this data set, not just the true underlying curve. Again I am repeating, see the it fit the noise in the data, not just the true underlying curve. So this is why the extremely low training error but the poor ability to the predict the new data set. See, yes, we have a mean absolute error is a lower 1.82. See, the extremely lower training error, the training error is lower, but with respect to ability to predict the new data set, it's much poor. That the scenario we can say this model is overfit. That means the model perform well with the training data set and it's failed to perform with the testing data set. So you can able to see there the training mean absolute error which is nothing 1.83. This is the it's a very extremely low training error. There is no low training error, but with respect to ability to predict the new data point, it's a very poor. So in this particular scenario we can say this model is the overfit. That means the model perform well with the training data set but it's failed to perform with the testing data set. And then technical what is the low bias and high variance. That's all for today. So please guys do not forget to like, subscribe my channel. Thank you so much for watching this video. Bye bye.